which model is more consistent with the data, for frequency or density. And again, here is a quick summary of our results. So again, looking at the AIC value, results were more consistent with frequency-dependent transmission, which is bad news, because when you have density-dependent, you can either apply culling below a certain threshold, but when it's frequency-dependent, essentially you need to cull the entire population. And obviously that's unfeasible. So, so we also were able to establish a range of introduction time, probably somewhere between 41 to 200 years, and we were able to estimate the transmission coefficients, which we then used to populate the model and run some other simulation where we simulated different intervention mechanisms. So I'll skip the leishmaniasis because I gave that talk about 4 years ago, I think. So anyway, so this is a classic system, again, beautiful system ecologically, and as you all know, there's the Leishmania major is pretty much endemic, but the tropica, the one with the Hyrax, is relatively new, and it's a system that could that could really benefit from collaboration of ecologists and epidemiologists. So let's go to the end. So again, I guess the point that I was trying to make, and somewhat preaching to the choir, that there is a really strong need for interdisciplinary studies between ecologists, zoologists, and the health disciplines. That's it. I guess there's no time.
Thank you. So questions you get on in the break. And last but not least, speaker is coming from New Zealand, Edda Sally. We'll talk about benthic invertebrates.
The last.
Last.
I knew this would be.
Over here.
I knew this would be the last one, and everybody would be tired, so I tried to make it as easy to digest as I could. Effects of river water abstraction on benthic macroinvertebrates. These are the macroinvertebrates I'm talking about. They live in the river which I am studying. The same river from where these sprinklers abstract water to irrigate these dry lands of Otago, which would not have been this green hadn't it been for these sprinklers.
That's an Israeli invention.
Oh, I didn't know. No, actually, this is Israeli. The sprinklers are, I think, here the company which. Yeah. So the lush green fields support sheep and fruit farming in the region, which New Zealand is very famous for. The farmers are not restricted to take even 100% of that water. So the regional council in that region is changing those permits to cap the allocations, the limitless allocation of water in the region. And by law, they should do this by 2021. And we're at the end of 2019. It'll be 2021 soon. It is the time is very short, but they're not alone. The regional council is not alone, and I'll explain that as we go to the Bangkok airport. At the airport, there is a statue of this story from Hindu scriptures where the demons and the lords realized that if they churned out the ocean, they would have elixir of life. What they didn't know, that they would also churn out poison. So Lord Shiva had to come down from the Himalayas and drink that poison to preserve humanity. Now, my analogy is that the stakeholders, fishermen and farmers, churn out river resources and do not understand the consequences that they might have on our planet. So, Lord Shiva is the embodiment of the regional council, of scientists like us, the national government, where we all need to collaborate, like the person before me insisted that collaboration is very important if we need to save our planet or use any of our resources sustainably. So the research community in one of the regions of New Zealand studied 3 water takes on a river, which is, water takes as is to say, these are the points where majorly from the river water is abstracted from 50 to 99%. This is the picture of one of those water takes. This did not exist till 100 years ago. That's the natural course of the river. The farmers have put these bunds, and more than 50% of this water is allocated into irrigation fields. So I read literature and also by common sense, the habitat will be reduced, river width will be lower, velocity will be lower, depth of the river will be lower. So I assumed that there would be effect on abundance and community structure of the fauna in the river. And because invertebrates reflect health of the river, they are the food source of the fish, and they have a very huge diversity. I chose to study the effects of water abstraction not on fish, but on invertebrates. In this river system, I had a very good experimental design, which is not good for the river, but it's good for my master's thesis, in which, in summer period, that's the period when the farmers take water. It's also the period when there is naturally low water levels in the river. So the red triangle points where the water abstraction is. So the first occasion is showing that naturally, when there was low water upstream of the water gate, farmers take it and it reduces. Then when water returns naturally to, in winter season start, farmers stop taking water because lands freeze in that area, they don't need water anymore. And water then increases till the next irrigation period. So these were my 3 occasions of study. So I could study the persistence of this effect, of what this would have affected the invertebrates later too. Riffle samples are just taking a fixed area of the riverbed and scooping out whatever invertebrates I could take, and I tried to identify them till genus level. So, you would expect the physical habitat to reduce, and these are 1, 2, and 3 are my 3 sites of study. In the first occasion, this occasion, blue is upstream and red is downstream. In all 3 takes, this is discharge or volume of flow. You can see, I should add error bars, I know. There is reduction in discharge. This is significant when you test it too, and so this discharge, reduction in discharge downstream of the take is reflected in depth, velocity, and wet width of the river. Now, I ask you, though you're only, 6, 7, what would you expect? If the water is less, what would you expect the invertebrates to react or respond? How do you think they would respond? What would happen?
Local extension.
Different species. Okay, different species, that's what I expected. What did you?
Local extension.
Yeah, he said local extinction. Anything else? If there are 10 upstream, I expected them to be maybe half downstream. So I wanted to see a difference between species and in abundance. These were my 2 factors. And this graph is for my first take. I had 3 takes, so this is my first. And I showed you 3 occasions during and after 1 and after 2. I had 2 occasions when abstraction stopped. And the blue again shows upstream density of invertebrates in that fixed area of the stream, and red shows downstream densities. So in all seasons, the first thing to see, in all seasons, red is lower than blue. It is naturally decreasing, the density is naturally decreasing, but that decrease is accentuated downstream. And the similar result was seen in both the other 2 takes too. This means that though naturally density decreases, as water will come back, they will have to recolonize and density does increase naturally. But due to water abstraction, that decrease is accentuated. I should have shown classifiers that the difference between blue and blue is not significant, but the difference between red and last red is very significant. So water abstraction causes reduction in abundance, and the decrease in density is accentuated downstream. So when I wanted to see if there was local extinction or reduction in species, no, there was no such change in species. But what I did find was that downstream of the abstraction, there was relatively more abundance of those species which regenerate quickly, which makes sense. Dipterans, for example, mosquito larvae, they have weeks or even just 1 month maximum of regeneration. They were relatively equally distributed, while these species, these taxa, for example, Trichoptera, Coleoptera, and Ephemeroptera, these were relatively less abundant, but they were present. So life history is what's dictating the relative abundance of species upstream and downstream. And to add to the information, now that I've had species data and abundance data, I tried to compare them upstream and downstream. So instead of finding a difference between species upstream and downstream, I found some other difference. There is a more difference. This is an ordination of all taxa abundances. Instead, I found that due to season, there is more change in the species richness of the river rather than due to water abstraction. And there are many indices that you can calculate to study. Somebody did beta diversity, I did that too. I tried all the indices that I could find for my data. I calculated them all, trying to find some difference to publish and make a statement, but there is no local extinction. The community is very resilient. I wanted to show one of the examples of the indices that I calculated. It's called Macroinvertebrate Community Index. It reflects presence or absence of sensitive species. In this graph, I plotted all the three locations that I had, that I pointed out. This is upstream and downstream. So what happened, rather than finding an upstream-downstream distribution, I found that richness in upland areas of the river, headwaters, where the streams are, have higher number of sensitive species or higher richness than those that are near the sea or entering the sea. So that may be due to nutrient enrichment and pollution. This is less, but upstream and downstream, due to water abstraction, there is no change in community structure, seen both by ordination and univariate graphs. In summary, I explained that the abundance downstream decreases due to water abstraction, and that there is a decrease in density due to natural flow influx of water, which is just accentuated by water abstraction. And when I try to see the relative abundances, it is the organisms or taxa with longer life histories that are more affected than taxa with shorter life histories. So how does this correlate with the bigger picture? If there is less food, there will be less food for fish that are used for fishing and native endemic fish which are endangered in the region. Now the scientific community has done its work. And we say that production capacity in the river is determined by the minimum flow in the river which the farmers let. So it's up to the policymakers now where they want to put the limits so that they can save, or no, it's their choice. It's their choice now. So that's all the people that helped me throughout: my mom, my supervisor, the research scholarship, my other supervisor who's so off social media I couldn't get a picture. They're all my people from my department. That's my research assistant. He's from USA and he's been great help. Those are other people. Thank you so much. I hope I got you.
Nice. Okay, questions? Can you relate the decrease in abundance to shift toward the dormant cell life stages? diapause, you know?
Oh yeah, diapause. Yes, so the species which will have longer life histories, which have diapause in them, will probably be less. But in this case, in my case, all these species were good at, the temperatures fluctuate only from 5 degrees to 20 degrees, and that's the only one, so they hardly any of them undergo diapause. They're well adapted.
The fluctuations in the depth of the water and the velocity, are they bigger than fluctuations in smaller rivers, or because if it's...
So the velocity that I calculated was from 0.5 to 0.9, which is in both upstream and downstream, which cannot be taken as slow. So I did try to find a difference between fast flowing and slow flowing species above and below, but I couldn't make that relation. I do have a, so there is another index. It's related to flow and velocity. It's called Lotic Index for evaluation of invertebrates in New Zealand. These are the indices for it, and they're all range. The range is so small, it's 7.5 to 8. They do not show any response to velocity because it's good enough. It's not bad.
But there are rivers where the abstraction of water is almost 100%, right?
Here in Yarkon, this happened that they took 99% and it depth reduced. Yes, of course, my study is very specific because they have. I chose this because it will make news, because in that region, this river, this stream is very important right now. All the money is going into research around this area. But yes, that's my PhD, to study gradient-wise velocity and flow in river.
Okay, very last question, great.
Yeah, I was wondering if when you take water out of the river and then it's put into the agricultural fields, at some point it will flow back into the river, I imagine. Do you know if when you did the extraction down the river, if you knew if that was past that point where it would rejoin and then it'd be affected by pesticides or chemicals? Or
Yeah, so I was here. So this is the river I study, and it is true in 1 or 2 cases the river water does return. But firstly, that return was done here when majorly the whole water take returns. Yes, that's true, and the whole area is around farmland. So even if the most upstream site, if I take that as control, even that is affected, so I could compare them. And secondly, what would I, so these 2 regions are still very downstream, but there is another river, there is another tributary that is influxing that, so I kind of think it will compare, but I do have to write this in my thesis after I research it very well. Thank you.
Okay, thank you so much.
Thank
And for speakers, and I have 3 announcements. Hanukkah countdowns, we're going to write them now in